For this section of the unit, we are going to use our knowledge of how we solve equations and apply them to inequalities. And the only difference between them, or the main difference between them, is that they don't have an equal sign, they have another symbol that you have to be familiar with. And then there are a little bit of details when you solve them and that the fact that you have to graph them that are different as well. But for the main part, you are using the same skill base that you have from equations to do inequalities. So the first thing we want to review and go over are the names of the symbols and what they look like. Less than is the one that points to the left. Less than or equal to has the less than symbol and a piece of the equal bar underneath it. Greater than points to the right. Greater than or equal to is the greater than symbol with a piece of the equal bar. Please make sure when you write your symbols, if you need the equal bar there, that we can see it, because if we can't see it, then it has to be marked wrong because it's not the right symbol. When we go to graph inequalities, and you've done these in the past, so this is just a refresher, you have to know about what the symbol is and how to graph it on the number line. So the two symbols that get used when we're graphing are what's called an open dot and a closed dot. Okay, so the open dot literally looks like an open O, and the closed dot is a closed O. The open dot gets used for the less than and greater than symbols, and the closed dot gets used for the less than equal to or greater equal to signs. The ones that have the equal bars get the closed dot. So for number one, when we're looking at graphing x is greater than -8, the first thing you've got to do is put some numbers on your number line. Now there's a lot of different marks on this number line. You don't need that many. As long as you can get 3 numbers on the number line, that shows us you know how to count, and we're okay with that. So if you put -8 right in the middle, then I always want to go 1 number to the left and 1 number to the right. So 1 below -8 is going to be -9. 1 above -8 is -7. Okay, and then I need to decide which dot I need. Because it's greater than symbol, I need an open dot, and you can put it right on the number line or you can graph it above it. Either one's fine, you just don't ever graph below it. And because it's greater than, all the numbers bigger than -8 are to the right. Now there's a little trick that you can use with graphing. If your variable is first, then the direction that the symbol is pointing is the direction that you're going to shade. Okay, but that's only if the variable's first. If it's not, then you want to reverse it so that that's always true. All right, so if you go over to number 2, k is less than or equal to 5. So when we have a less than or equal to sign, first thing we need to do is put our numbers on the number line. We put 5 in the middle, we have a 4 on the left and a 6 on the right. Most of the time, positive numbers you don't have a problem with. Some of you don't know how to count in the negative world, so we've got to be careful there, because if you miscount on your number line, everything you graph is wrong. All right, so watch out for that. With less than or equal to 5, you do want a solid dot on the 5. And because it's less than or equal to, that means everything's smaller than the 5. So that would be to the left. And again, the variable's on the left and it's pointing to the left, so you shade to the left. Okay, so use those symbols to help you out. Jump down to number 5. I want to show you that one as an example before we go to the next section. In number 5, the variable is not on the left. So the first thing you want to do before you even put numbers on the number line is you want to rewrite it so it says P first and 7 second. And then because you switch the order of the problem, you want to flip the sign around. It's pointing to the P originally, so when you reverse it, you keep it pointing to the P. All right, now we need to put our numbers on the number line. So 7 goes on the bottom, then 6 to the left and 8 to the right. A less than sign is going to be an open circle on 7 and shading to the left, because less than means left. Okay, and there's what the graph would look like. Do not use the trick about which way the sign is pointing because the variable was not on the left first. All right, when you go to the next section, we're talking about translating words into symbols, and then we're going to graph them after we translate them. So looking at number 8, a number is greater than or equal to -18. Right, so the a number part is your variable. I use the x generically. Is greater than or equal to would be the greater than or equal to symbol, and then -18. Every inequality you write has to have a variable, a symbol, and a number. Without it, it's not a true statement. All right, so then on our number line, we want to put -18 in the middle, -19 goes below it, -17 goes above it. And then because it's greater than or equal to, we want a solid dot on the -18. And greater than is going to go to the right. All right, when you go to number 10, a number is no more than 9. Right, so you've got to be careful with the phrase, and you actually have to think about what it's asking you. A number, that's your variable x, and then we know we need the number 9 in here. So the trick is getting the symbol right. No more than means you cannot go over 9, but you could be equal to 9. So we need the equal bar. Okay, and if you can't go over 9, then that means you have to be less than or equal to 9. Okay, so that's what we're going to be graphing. Put your 9 in the middle, 8 goes on the left, 10 goes on the right. Less than or equal to is going to be a solid dot on 9, and less than or equal to would be left. Okay, and then we'll go ahead and do number 11. A number is at most 40. Okay, so that means a number part is x. We know we need the number 40. Now we just have to figure out the symbol for at most. At most means that's the highest it could be. It cannot go over that amount. So that means it could be equal to 40, but it cannot go over 40. So if it can't go over 40, we want the less than or equal to symbol. Okay, so sometimes the wording is not exactly the way it sounds. If you stop and put it into a real life situation though, it would make more sense to you. So 40 goes on the number line, 39 below it, 41 above it. This would be a closed circle on 40, and less than or equal to would be left. Okay, so you'll be responsible for the other ones in that section. Okay, so now when we go to the solutions part down here in the bottom, the directions say to state whether the number is a solution to the given inequality. So they're giving you a number on the other side of the semicolon that they want you to see, does it work? So for number 12, the number they want us to test out is the 4. So we're going to replace the letter x with that number. So we're going to write the statement 4 is greater or equal to negative 6. And then we're going to ask ourselves, is that true or false? Okay, so is 4 bigger or equal to negative 6? That is a true statement. Right? So you can either write the word true or you can say yes or no. So true and false or yes or no, as long as you understand what you're doing with them. All right, so if we go to number 16 next, they're asking us about the decimal 1.7. So 1.7 is less than or equal to negative 1.6. Don't worry about the fact that it's decimals. Is a positive number smaller than a negative number? Never. So that would be a false statement. Okay, and then go ahead next to it, number 17. We want to put the fraction negative 3 over 2 is greater or equal to negative 9 over 5. Right? Now for this one, if you wanted to turn them into decimals to compare them, you could. Right? Or you could compare them as fractions. Right? But in this point, negative 3 over 2 is the decimal negative 1.5, and negative 9 over 5 is the decimal negative 1.8. So you're thinking about the world of negatives. The closer to 0 it is, the bigger it is. So is negative 1.5 closer to 0 than negative 1.8? And that is a true statement. So number 17 is true. Okay, so you're going to be responsible for the other ones in that section as well. When you flip it over to the back, now we're going to talk about solving. And for solving, we're going to start with the 1 and 2 step, but then later on you'll progress to even larger. Okay, so it's very similar to solving equations, but there is one major difference. All right, so if you look at the top where it says to solve inequalities, you follow the same steps as equations. All right, but here's the big one, and put next to it some stars, highlight it, do something to make it stand out. If you multiply or divide by a negative number, you must flip the inequality symbol. That is the one major rule that is different than equations, and that's the one you got to watch out for. All right, so each time I'll be asking you, and we'll be talking about, do you need to flip? All right, so let's go ahead and take a look at number 19 first. We want to solve it exactly like we would normally do. You get rid of the constant first, so instead of minus 6, you're going to add 6. For those of you who like the wall or the line, it's right where the symbol is. Don't cover up the symbol though. So you cancel out your 6's. Now you have a divided by 5 is less than or equal to 12. To get rid of divide by 5, you multiply by 5 on both sides. You did not multiply by a negative, so there is no point in switching the sign. A is less than or equal to 60 is your solution. Right? And then what you want to do after that is graph it. So we put 60 in the middle, 59 on the left, 61 on the right. Less than or equal to would be a closed dot on 60, and less than or equal to goes left. So you are responsible for solving it, showing your work, and graphing the inequality you come up with as a solution. All right, so if you'll go to number 20 next. Okay, again, a normal two-step inequality, so we're going to get rid of the constant first. You want to get rid of plus 22 by doing minus 22. All right, that leaves you with negative 2y is less than negative 4. And then to divide or to get rid of the negative 2, we want to divide by negative 2. You did divide by a negative, so now the symbol has to flip the other direction. Less than becomes greater than in this case. And negative 4 divided by negative 2 is positive 2. Right, so you might want to put a star next to number 20 because that one had the flipping rule that happened. All right, so you put 2 in the middle, 1 on the left, 3 on the right. Greater than would be an open dot on 2, and greater than shades to the right. All right, then if you'll go to number 23 next, we want to move the constant first, which would be the 4. It's a positive 4, so we want to subtract 4 from both sides. Now you have negative 3k is less than or equal to negative 27. You want to divide by negative 3 to get rid of the coefficient. And then because you divided by a negative, you want to flip the sign to greater than or equal to. And then negative 27 divided by negative 3 is positive 9. Again, put a star next to that one because the flipping rule applied there too. All right, so 9 goes in the middle, 8 goes to the left, 10 to the right. We want to put a closed dot on 9 because it's got a piece of the equal bar, and greater than or equal to is going to send it to the right. Okay, we'll do one more problem from this side. Okay. We'll go to number 25. Okay, this is the rule breaker question. It's the one that doesn't follow move the constant first and then move the coefficient. You can't move the constant because the constant's trapped in the division problem. So the first step you have to do is multiply by negative 4 so that the top becomes free. Right now it's trapped. So when you multiply by negative 4, it crosses off your negative 4. That leaves p plus 9. We multiplied by a negative 4, so you want to flip your sign the other way, and negative 5 times negative 4 is positive 20. If you don't move the negative 4 first, there is absolutely no way you can get an answer off this problem. Now that we've got the negative 4 gone, you can see there's only one more thing we need to do, and now we can move the constant. We can subtract 9 from both sides. We don't need to flip a sign because we didn't divide or multiply. P is going to be greater than 11. So when you go to do your number line, you're going to put 11 on the middle, 10 on the left, 12 on the right. It's going to have an open circle because there's no piece of the equal bar, and greater goes to the right. Okay, so now that you've seen examples in every section along these page of notes, your job is to go back and do all the ones that were not done in this video and show them to your teacher as proof that you have completed the assignment.